Well, it's another day. Um, just jump right into it. One of the things that I have been, I don't know if struggling with is the right phrase, but um, because I've been doing everything in Java, you essentially, to try Trepo, you have to have Java 7 installed, download everything, compile it, get it running, and then get the front end going and point the front end to the back end, etc., 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 etc. Which is a problem because it's not very easy. You can't just say, "Hey, go to blah domain name and try it out." Um, there's also the problem of if I'm going to move forward with TreeHub, I don't want to have to spin up a new back end every time someone wants to try something. It should be client side. Trepo was designed initially to be able to be run in a multiple, in multiple environments simultaneously, one of which being a browser. So to that effect, I need to look at starting. I need to start working on the front end code. It's not that I'm going to stop on the back end, but that the back end taught me a lot of lessons. Kind of the zero point 0.1 iteration through that let me build out the full stack. I also need to go work on the front end and do that. The nice thing is using ES6, I'll be able to take a lot of the algorithms. It'll be it'll be a quick process. Um, so that's the direction I'm going. Enter Vagabond. Ta-da! So Vagabond is just a JavaScript graph database. I looked out there. There's one called Helio JS. There's a couple other smaller ones, but there's no real true no or JavaScript specific graph database. So I was going through the requirements of a graph database, just thinking, and I was going, well, I have to make it synchronous and whatnot, and there's a graph database built on Level Up or Level DB um, that is for triples in a triple store, and I was like, well, can I use that? No, not really, because I need edges. Edges are first class. So I was like, okay, well, if I don't do that, how do I fit? How do I fit a graph database? They were using Level Up underneath the covers, and that's you can implement the triples using a hexa store. You essentially store everything 6 times, and you get index free adjacency. And then I realized, okay, for the use case that I'm talking about, we're talking about a large repository is like 10,000 people. And it's probably not all going to be one, but that's kind of a larger case, which is only about 1 million nodes. So we're not talking really, really big numbers here. Can we just do this in memory? And for now, I think we can. Eventually, it will be a problem. We'll run into issues, but with some nice lazy loading tricks and swapping in and out, as long as you have a nice fast key value store available, you can just do everything in memory with a asynchronous persistence mechanism, or even a persistent or a synchronous persistence mechanism, depending on speed and toggling. So I was thinking, okay, well, I'll just do that. I'll make an in-memory graph database that is analogous to kind of Tinkerpop's or Tinkerpop's blueprints or like Neo4j embedded. I was like, okay, I'll just do that. And I'm going to use ES6. I'm going to use classes and other things. So I had Babel, however you say it, which essentially is a transpiler. So you take ES6, which is the new JavaScript stuff, and you write it, and then it transpiles it back into ES5, which will run on all the major browsers. So you get all the syntactic sugar and all the nice stuff, but and you can run it everywhere. So I started this repository, and so there's Vagabond. So it uses, so you notice testing, uses the Babel compiler, and then dev dependencies, Babel, which I'm not sure is required. Well, whatever. So our library, I just threw this together kind of as a proof. I don't know, not even proof of concept, but a proof of ES6, how you write modules and stuff. So we got classes, we got constructors, we got this, we've got the new method syntax. In our tests, I wrote that. So we have import graph from graph, let expect equals this, using let instead of var, ha ha ha, locally scoped with errors, or error possibilities. And then we say, let graph here, graph.add node, just a semicolon, oops, this is all test stuff. And then expect, graph.get node.label to equal this. It's there. Dun, dun, dun. So, that's pretty much it for today. This is what I've worked on so far this morning. I think I mentioned that I turned in, I did my submissions, all the Roots Tech submissions. Those are all done, taken care of, finished. Can't remember if I said that already. Whatever. But then I'll be working on this. Essentially, I'll have to write this, and then vgraph will be really easy because all of the algorithms are already done. It's just a matter of taking Java code and putting it into JavaScript. I don't need decap. I can do ptree really, really easy because we're native JSON. Thank you. And then what I can do is Trepo. I can create two things. I can create endpoints that can be served up by something like an Express server. Or I can create kind of an internal, I'm not sure what to call it, internal something or other, internal SDK, and then I can embed this locally into web pages. And now I have a Trepo instance that's local, nice and speedy, fast. It'll just work. And I can take a clone. I can do a clone of another, one that's in the Java, import it into here, and it works. Woohoo! So, yeah, that's where I am moving forward with that. I will also be working on the front end. I need to get that done. So this will give me the opportunity to dive back in and I can work on this a little bit and feel satisfied about cranking out some like back-end code that I like cranking out. And then I work in the front end and I can also work in Java. So I'll just kind of be working everywhere, moving things forward. It just feels right to do this. So that's it for today. Take care, have some fun, and see you.